adding and subtracting mixed fractions with like denominator. We've taken a moment to see what fractions look like and how we represent numbers of the fractions with our horizontal bars. Okay. When we were working with the horizontal bars, we created some fractions. In those fractions, we had a denominator on the bottom, and a numerator on top. The denominator is the number below the bar in a fraction. Okay? A numerator is the number above the bar in a fraction. Yes?
Didn't you say how to add and subtract mixed numbers?
I was just showing you to remember that the denominator is always on the bottom and the numerator is always on the top. Okay? So here's a representation of mixed fractions. This we're looking at, instead of horizontal bars, we're looking at pizzas. So our pizzas from this pizza shop always had 8 slices. 1, 2, 3, 4, 5, 6, 7, 8. So one whole pizza, another whole pizza, and another whole pizza. That's how many whole pizzas? 3. Okay? This pizza, where this is shaded, we're going to say that one got eaten. That slice is gone. So how many slices got eaten? 1, 2, 3, 4, 5, 6. Ooh. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 7 got eaten. Very good. On this one, how many slices got eaten?
1, 2, 3, 4, 5.
5. On this one, how many got eaten?
1, 2, 3, 4, 5, 6.
Okay. Now that's how it looks just looking at pizza, but we can represent this with fractions.
Oh.
Okay. So we talked about how many pieces got eaten, but how many pieces are left? Let's make some fractions out of that. Okay. Madison, would you like to do that? Why don't you do this first pizza for me?
That would be
1 and 1/8. So we have 1 pizza and 1/8 of the pizza left. Okay? Tamara, you look like you're ready to go. Would you like to tell me on this pizza, these 2 pizzas, how many slices are left? 1 and 3/8. Does the 1 represent this entire pizza? And the 3 represents how many pieces are left? Okay? Kance? Okay, Kance, would you like to do this bottom one for me? How many?
1 and 1/4.
1 and 1/4. Now, he's going to trick us up here. He went ahead and simplified, because right now, there's 1 whole pizza, the 1 represents this. There's 2 slices of an 8. He's simplified. He went a step ahead for us, that 2 8s can also equal 1/4. Good job, Kance. Okay. All right. Now here's another set of mixed fractions. We have, this would be just like saying there was 1 pizza and 1/8 left, 1 pizza and 3/8 left, 1 pizza and 2/8 left. Those are the fractions we had before. Okay? When you're adding mixed fractions, you're going to take the whole numbers and add them first. So 1 plus 1 plus 1 equals 3. Now, when you're adding the fractions, you need to make sure that the denominators are alike. And I've highlighted to show you that they are alike, are they not?
Yeah.
Okay. So if they're alike, then you're just going to go ahead and write down the 8, because it's representing the 8 slices that we were dealing with. Now we can add how many slices in total were left. Would you like to do that, Zach? Yes. This one, this one, this one. So 1 plus 3 plus 2, 6. All right? So make sure you can see that. So we have 3 whole pizzas, 6 8 slices left. If you simplify that, you can divide both of these numbers by 2, and it becomes 3/4. So there were 3 whole pizzas and 3/4 of the pizza left. thought I would throw this out for you. This is just a bunch of arrows to show the steps that you would go through when you have a big group of numbers. So right here, we have 2 and 9/8 plus 4 and 3/8 plus 1 and 5/8. So the first step is to what?
Add the whole numbers.
Okay. Shelby, could you add the whole numbers for me?
Yeah, if you add 2 plus 4 is 6 plus 1 is 7.
Good job. And right here is our 7. Now, are the denominators alike?
Yes.
They're about the same, so we can just go ahead and put the denominator right here in the solution. Now we need to add the numerators. So, right, Tristan, would you like to add the numerators next?
9 plus 3 is 12 plus 5 16 means 17.
17. Very good. So we have 7 and 17/8 because the 8 is still the pizzas that we represented that had 8 slices per pizza. Now right now, this is called an improper fraction because the numerator is larger than the denominator, and we can't let it stay that way, can we? So here's what you do to find the mixed number of that improper fraction. You're going to take the numerator and put it right here, and you're going to divide it by 8. So 17 divided by 8. How many times will 8 go into 17? Tamara?
2.
And then 2 times 8 is, oops, 16. Don't forget that the 8 is supposed to be 16, but I did have it right here. It is 1, right, is left over, and that was 16.
Is that a power?
Yeah. So anyway, it would be a remainder of 1. Okay. So when I have this 2 plus this 7 right here, the whole numbers equals 9. That's where I got this 9 from. And that remainder of 1/8 right here is put beside the whole number. Okay. All right. Now on your desk right here, I just left it there. We'll put this in later. We're going to keep on working, but these are the math notes that I've given you. And we're going to use these when we're adding and subtracting fractions. So adding mixed fractions, to add the mixed fractions, you add the whole parts of the mixed fractions first, and then you add the fraction parts, just like we had done. And they're giving us an example of 2 1/7 plus 3 and 2/7. Okay? And the solution they're showing us that you add the whole numbers right here, the 2 and the 3, and then you add the fractions. So it ends up being 5 and 3/7. Okay? Now subtracting is no different. The only difference is you will be subtracting. Okay? So right here is our example. Well, let's start here. To subtract mixed fractions, you subtract the whole parts of the mixed fractions first, and then the fraction parts. But here's the trick we need to make sure you know how to do. Well, what do you do if the left side of the fraction part is smaller than the right side of the fraction part? So if you have 7 and 2/5 minus 2 and 4/5, of course we can take 7 minus 2 and get something, but can I subtract 4 from the 2? Because this number is smaller than the 4. So somehow we need to find a way to give this number more parts. Tristan? You're going to regroup. Very good. So I can take away a whole number and create a 2/2 because 2/2 equals a whole number. So that's what they've done right here. 7 minus 2 is 5. And then 2/5 minus 4/5, therein lies the problem. You can't do that. So they take 1 from the 5 that's left, and they add it to the 2/5. Because we remember that 1 equals 5 over 5. So we end up, because we took 1 away from the 5, we end up with 4. And then you can add that 1, which is represented by 5 over 5, plus 2/5 minus the 4/5. So this added to this will make the fraction large enough to be able to subtract. Okay? Remember how we regroup before? Okay. So 4 plus, you subtract the 7/5 from the 4/5, and it equals 7 minus 4 equals 3. So it's 4 3/5. Okay. Now let's do something fun. Okay? I'm going to let